On April 3rd, 1860, the Central Overland California and Pikes Peak Express Company, the Pony Express, began operation. It revolutionized movement of information by transporting letters from St. Joseph, Missouri to Sacramento, California, a distance of roughly 1,500 miles, in only 10 days. On October 21st, 1861, Western Union spliced its eastern and western wires together, thus creating the first transcontinental telegraph network. Just 3 days later, after less than 19 months in service, the Pony Express went out of business, displaced by the rise of electronic data communication, and we're still finding ways to move data faster, in bigger quantities, and more securely. Hi, this is Gary. This is Gary on manufacturing. And as always, this podcast is brought to you by Ignition from Inductive Automation. For your HMI SCADA needs, check out inductiveautomation.com. And I thank the fine folks at Inductive for sponsoring this podcast and my website. Without it, I couldn't bring it to you. This is a part of a talk that I gave to the Industry of Things World East event in Orlando, Florida, in the middle of November. The Industry of Things people bring actually many conferences, and I have been impressed with the way they could put together conferences from Berlin, Germany, and make them successful in the United States and other places. They do an Industry of Things World event in San Diego in March, in July in Singapore, in September typically in Berlin, Germany, and this year they tried one in November in Orlando. It was an interesting conference, some really good speakers. I was pleased that I was able to make a short presentation of about 15 to 20 minutes, plus questions then. But it was a good opportunity, and check out Industry of Things World for future opportunities. So I wanted to talk about data, starting with the Pony Express and letters, and then to electronic data. And we have been doing data for quite some time. We collect data, the PLCs collect sensor data. We've been doing that for 30 years. Sometimes we pass it on. Sometimes we would like to pass along a lot more data. But sometimes it just goes into a historian and dies. It just kind of sits there as if in a tomb, maybe to come out someday, most likely not. We forget sometimes in our rush to do all these technology things, what's the purpose? I became a mentee of W. Edward Stemming a long time ago when I was a quality assurance manager. And he said that the ultimate purpose of collecting data is to provide a basis for action or recommendation. In other words, we shouldn't just collect data to collect data. We should be collecting data that we can use to solve a problem. Maybe it's a production problem, maybe it's a people problem, maybe it's a business problem. I have a cartoon where they're meeting trying to figure out something, and somebody says, what if we don't change it all and something magical just happens? A lot of us in our careers have seen management like that. Why don't we just wait for something magical to happen? Well, the magic is in a lot of stuff that we do. The technology we have is magical, and we can collect so much more data, for example, and move it so much faster, and we just keep getting better and better. We've gone from analog serial communications in RS-232, if you remember those days, and RS-485, and then we went into field buses, and we had DeviceNet and Profinet, or DeviceNet, Profibus, and so on. And then Ethernet took over in a big way, almost out of nowhere. I can remember writing about Ethernet, and people said, "What are you doing that?" And the next thing I knew, everybody's using Ethernet. And we just keep on going. We have new technologies. We have time-sensitive networking that's going to take Ethernet to the next level. And so we do all this, but we forget what's the real reason. When I did my first manufacturing software application some 40 years ago, I was taught some basics, and those basics haven't changed. To this day, I'll interview people and I'll see the fallacy where they didn't follow some basic principles. First one is make sure you have good data. If you're going to put in a system, make sure you have a good, reliable, steady, fast source of manufacturing data. The second thing is make sure you understand your process. Before you do anything, understand what you're doing. You can't even change it if you don't know what you're doing to change it. You need first to understand your process, then you could put it in a computer, then you can start to rationalize things and figure out where to make changes and where to improve and so on. All the data that we have is a great asset to Lean. If you're doing Lean Kaizen events, it's really useful to know, who, what, when, where, and how, and the data really helps. So we need to remember that we're doing all this, and we're doing it to solve business problems. Data flow has been kind of tortured over the years. In the early days, we had what was called the pyramid, or the Purdue reference model, and in that case, the data was basically control data, and it came from a physical layer of not so smart devices through a PLC that added a little bit of context, and then structured up through a SCADA system or an HMI system, and on up into the MES and then the ERP, the enterprise systems. It was a pretty structured, siloed kind of data flow. And then we added a safety data flow later when we started doing better safety systems, especially in process, but also in discrete. And so then we had a control data flow and a safety data flow, but if somebody in their MES system or their ERP system needed some specific manufacturing data, it was hard to get. They had to go to a control engineer or a process engineer and get into the guts of the control system and get the data out. That's a dangerous thing. Every time you mess with a program, it changes something, it seems like. And so we had to figure out ways, or we needed better, to get out of this silo of things, and we need another stream. We need an Internet of Things data stream. We need a data stream where data can flow from the source, whatever it might be, to the consumer, wherever that might be. So it's kind of a producer-consumer model. We need it not to go through any structured hierarchy, but if an application at the enterprise level needs some flow information out of a process down in the factory, in the plant, it should be able to reach into there and get it without having to go through any rigmarole of the process control system and mess anything up. The data should just be sitting there and saying, okay, suck it up. Okay, I can run this calculation, and now I can do my customer service report or whatever information I might need downstream. So we need a new model, and there are many models being developed by people to show the breakdown of all these silos and the structured layers of the MES or the pyramid system into a producer-consumer, whatever produces data flows to whatever needs it. Now we start talking about breaking down all this. We need to start breaking down the silo that's an artificial silo that's been built up and hardened, and it's almost like concrete bunkers, and that's IT/OT. It's crazy. We don't need IT people having to get special permission to talk to an OT person to get a piece of data that they need. We need to break down those barriers, both organizationally, which is very important. I just replied to somebody on LinkedIn that it's as much a people problem as it is a technology problem, and maybe I should say it's a management problem. Good managers would be breaking down these silos and offering ways of collaboration for enterprise IT people and operations technology and information people so that they can share ideas and systems. Who's a security expert? They should be working both ways. Who's a networking expert? Who knows databases? We need to be working together to do all that. One of the examples I had that I shared with my audience was a refinery of the future from Houston, Texas, called Texmark Chemicals. I visited a couple times. I've written about it on themanufacturingconnection.com, and you can look up Texmark Chemicals. I learned about this company actually through an IT company called Hewlett Packard Enterprise, and they were primed. They actually went into the refinery and they were talking, said, well, we got this problem. The insurance company came in and said, we need to start collecting, doing some stuff and upgrading some things. We're not really sure where to start. And they said, well, we have an IoT lab. Maybe you need Internet of Things. And they said, oh, I don't know, what's that? Let's go. So they rented a party bus, as they called it, took 15 employees, and they drove down the road into Houston to visit the IoT lab at Hewlett Packard Enterprise, or HPE. And they weren't sure on the way down. They're just, talking football and whatever. And they get down and they tour the lab and they see a Flowserve pump demo. And they see National Instruments instrumentation and they see other operation technology things. They said, oh, this is useful. And on the way back to their facility, instead of talking football, they're talking, where can we use this stuff? I could use it here. I could use it there. I could use it here. And so they had a team and they sat down and said, what is our most critical process? The first thing that we should really do as a pilot project for using Internet of Things to solve a business and process problem. And so they picked a pump that's crucial. If the pump goes down, the process goes down. There's no workarounds. And so they instrumented it with wireless sensors and put in a mini data center from HPE. They put in some robust wireless systems so that they could move data from the sensor or from other places and send it to other places. And they put in the system and immediately they started to see all kinds of results. They reduced operator or maintenance technician rounds who had to go around physically look at things. They were able to add to this IoT system a streaming video to when they had to open their gates up to allow a railway car to come in. They also allowed critters to sneak in, and coyotes are a problem, and they didn't want any loose coyotes just kind of walking around the facility. So they set up a system that monitored whenever the gate was open, and if if the system actually saw a coyote coming in, they could take action to help the coyote leave the facility before it hurt anybody. They started enumerating multiple benefits, and you can read about many of them on my blog. But it proved that Internet of Things technology, properly applied, can save a lot of problems, and it can make money, and it can alleviate hazards and things that made the insurance company happy. And then they could go on and they started to develop more ideas and more things that they could do. One of the things this whole thing takes is an ecosystem. So it wasn't just Hewlett Packard Enterprise. They brought in Intel for the video. They brought in a company to do the dashboards and put together some of that software analytics part of it. They brought in National Instruments for instrumentation. They brought in, other, in the end, there were like 12 companies that they brought in to build an ecosystem, and it all plugged because of modern standards and technologies. They could all plug it together and work it and put in the system. I've had a lot of problems with our data story and doing these things just to apply technology, or we've got stuff buried that we didn't know about. That even was there, stuff that we could have brought together and solved problems we weren't even looking at. So I took a look at a quote from Albert Einstein, who said, if I had 60 minutes to solve a problem, I'd spend 55 minutes defining it, 5 minutes solving it. I think we've been jumping right into the solving it without spending the 55 minutes of defining, and part of that defining is defining our data flows, getting the data in there, defining who needs to know what, make sure we're collecting the right data and not just all data, making sure that we're analyzing it properly, making sure we can visualize it in the right roles to the right people, and so on. I learned early on, do the preliminary work first, and then solve the problem. I was listening to my friend Charlie Gifford speak at one of the keynotes, and he was talking about rationalizing operations to ISA 95 and how he talked to executives, and he said, well, but that's so much work. And he says, Well, exactly. We need to do that upfront work. That's called engineering. That's what we were trained in. That's what we need to do. So anyway, that's a brief look at the talk I gave at the Industry of Things East conference in Orlando last week, in the middle of November, and take a look at future Internet of Things, Industry of Things world events. They're always very good, very informative. You learn a lot, and you meet a lot of really cool people. This is Gary Minchell, and this podcast has been brought to you by Ignition from Inductive Automation. Check out my friends at inductiveautomation.com for your HMI SCADA needs. Thank you.